What if the universe has no end? Imagine standing on the edge of existence, looking out into the blackness, and realizing there is no boundary, no final curtain that closes around the cosmic stage. For centuries, humans have dreamed of the edge of everything, a place where the stars fade and the void begins. But modern science suggests that such an edge may not exist. Instead, we may be drifting inside a reality that stretches on forever, a universe without walls, without limits, without an ending at all. This idea is both terrifying and beautiful. On a human scale, we crave closure, beginnings and endings, frames that tell us where the story stops. The thought that the universe refuses to conform to that desire challenges our imagination. When ancient stargazers tilted their heads back and traced the constellations, they imagined the cosmos as a dome, a celestial sphere wrapped around Earth. The Greeks pictured crystalline shells holding the planets. Medieval scholars thought the firmament was finite, with heaven beyond. Every culture placed a border on reality. Yet as telescopes grew more powerful, those borders dissolved. The farther we looked, the more galaxies appeared. It was as if the universe was taunting us with its endlessness. Edwin Hubble's discoveries in the 1920s shattered the last illusions of a static, finite cosmos. He revealed that the universe was not only vast, but expanding. Galaxies rushing away from each other, carried on a fabric of space itself that seemed to stretch like an inflating balloon. That expansion raised a profound question. If everything is rushing outward, what lies at the edge? But the answer came like a riddle. There is no edge. In the balloon analogy, galaxies are like dots on the surface. The surface has no boundary. Walk far enough and you circle back. Space, it seemed, could be finite, yet unbounded, or it might be truly infinite, extending beyond any imaginable horizon. Cosmologists today wrestle with this question using the most advanced tools: satellite observatories that map the afterglow of the Big Bang, particle accelerators that probe the quantum froth of existence, and supercomputers that simulate the birth of galaxies. The evidence hints that the universe is astonishingly flat on the largest scales, like a sheet of paper without curvature. A flat universe suggests that it could be infinite, never looping back on itself. If this is true, then the portion we see through our telescopes is only a grain of sand on an endless beach. Beyond the limits of our observable cosmos, a sphere about 93 billion light-years across, there could be unending chains of galaxies, stars, and worlds stretching into the darkness without limit. But infinity is slippery. In mathematics, it is an abstraction, a concept without measure. In physics, it provokes unease. Can nature truly allow infinity, or is it merely a sign that our theories are incomplete? Scientists argue fiercely. Some propose that the universe is indeed endless. Others suggest it might be finite but so vast we cannot tell the difference. And still others point toward even stranger possibilities, that our universe is just one bubble among countless others in an eternal multiverse. What would it mean then to exist in a cosmos with no end? To live in a place where the notion of totality is meaningless, where there is always more beyond? The question pulls us deeper into the physics of space itself, into the very origin of the universe, and the enigma of what, if anything, lies beyond the horizon of our sight. To explore what it means for the universe to have no end, we must first confront the horizon that cages our perception. No matter how powerful our telescopes, we cannot see beyond the so-called cosmic microwave background, the faint radiation left from the birth of the universe nearly 13.8 billion years ago. It is the oldest light, a wall of fog through which no photons from earlier times can reach us. Beyond that horizon, there may be more galaxies, more stars, more space, but their light has not yet had time to arrive. The speed of light is both our guide and our jailer, limiting what we can observe. And so, in a sense, the edge of the observable universe is not a real edge at all. It is a boundary drawn by time, not by space. This distinction matters. If the universe is infinite, then what lies beyond that horizon is simply more of the same. Endless chains of galaxies arranged in structures we can only guess at. But if the universe is finite, then perhaps it loops back on itself in unexpected ways. Imagine traveling in a perfectly straight line for billions of years across unimaginable distances, only to return to your starting point without ever encountering a wall. This is the idea of a finite but unbounded cosmos, a shape that defies intuition but can be described by the mathematics of geometry. Some cosmologists compare it to the surface of a sphere, but extended into higher dimensions. The shape of space is one of the deepest mysteries in modern cosmology. Einstein's theory of general relativity showed that matter and energy bend space and time, warping the geometry of the universe. Depending on the total density of matter and energy, the cosmos could curve back on itself like a sphere, stretch endlessly like a flat plane, or curl outward like a saddle. Measurements of the cosmic microwave background suggest an astonishing near flatness, so precise that, within observational error, the universe looks infinite. But near flat leaves room for doubt. Could it be that on scales far beyond our horizon, the geometry bends in ways we cannot yet detect? Such questions are not new. In the 19th century, mathematicians like Bernhard Riemann developed the tools of non-Euclidean geometry, imagining spaces where straight lines curve and parallel lines meet. These ideas seemed abstract, detached from reality, until Einstein revealed they were the language of the cosmos itself. Suddenly, the shape of space became not only a mathematical curiosity, but a physical truth with consequences for the destiny of everything. If the universe is infinite and flat, then expansion may continue forever, carrying galaxies farther and farther apart until each becomes isolated in the dark. If it is finite and curved, then expansion might someday slow, halt, and reverse, collapsing everything into a final catastrophic implosion known as the Big Crunch. Yet the discovery of dark energy in the late 1990s rewrote that script. Observations of distant supernovae revealed that the universe is not just expanding, it is accelerating, driven by a mysterious repulsive force embedded in the fabric of space itself. This finding stunned cosmologists. It meant that even if the universe is finite, its expansion will not stop. Space will continue to swell, galaxies will drift beyond sight, and the night sky will grow ever emptier. An infinite future unfolding into an infinite silence. And here the question of infinity deepens. If space can expand forever, then what exactly is it expanding into? This is a trap of the human imagination. We picture a balloon inflating into surrounding air, but in cosmology, there is no outside. Space itself stretches. The universe does not grow into a larger void. The void is created as part of the process. There is no beyond, no external theater in which the cosmos performs. Only the universe itself, possibly infinite, possibly eternal. But if infinity is real, if the universe truly has no end, then its implications are as dizzying as they are unsettling. Infinity does not simply mean a lot. It means that every possible arrangement of matter must exist somewhere, repeated without limit. In an infinite cosmos, there would be another Earth, not just similar, but identical, with another you watching this very film, thinking these very thoughts. Travel far enough, and you would find endless copies, variations of yourself, making different choices, living different lives. This is not science fiction born from fantasy. It is the logical consequence of infinity combined with the finite number of ways matter can be arranged. Somewhere, everything that can happen must happen. Such visions are difficult to accept. Many scientists are cautious, wary of declaring infinity as fact when it may simply be a reflection of the limits of our models. After all, our observable universe is finite. What lies beyond remains speculation. Some argue that infinity is a dangerous assumption, a placeholder for ignorance. Others embrace it, pointing to inflation theory, the idea that in the earliest fraction of a second after the Big Bang, the universe expanded faster than the speed of light. If inflation is eternal, spawning new regions of space without end, then infinity is not just possible but inevitable. Our visible universe would then be a single bubble in an eternal froth of universes, each perhaps with different laws of physics, different constants of nature, even different dimensions. And here the question of no end grows even stranger. If space is infinite, is time also infinite? Will the universe continue forever, or does it have a final act waiting, hidden in the far future? Some cosmologists foresee a heat death, where the expansion dilutes matter and energy so thoroughly that stars burn out, galaxies fade, and black holes evaporate into a cold, featureless emptiness. Others suggest a more violent end, a big rip, where dark energy grows stronger over time, tearing galaxies, stars, planets, even atoms themselves into nothingness. Both scenarios confront us with the paradox of endlessness, a universe that may stretch on without limit but leaves nothing within it to experience eternity. History reminds us how fragile our cosmic perspectives have always been. Once, Earth was the center of creation. Then it became a planet among planets, circling an ordinary star in a typical galaxy. Now we face the possibility that even our entire universe is not special, but one of countless others. With each step, the horizon recedes, and the idea of a final edge slips further from our grasp. The closer science looks, the more it seems that there is no boundary, no final wall, only deeper questions. And yet there is wonder in this boundlessness. If the universe has no end, then it is a stage vast enough to hold every possibility, every story, every mystery. It means that discovery itself is endless, that no matter how far we reach, there will always be more to know, more to see, more to imagine. The absence of an end is not a prison, but a liberation, an invitation to explore without ever fearing the final chapter. Still, the mind resists. We long for closure, for the comfort of edges. We imagine the universe as a book with a first and last page, but what if it is instead a story that loops, folds, or never stops unfolding? To grasp that, we must go beyond telescopes, beyond equations, into the very philosophy of existence itself. What does it mean to live in a universe without limits? And what does that say about us, creatures who hunger for endings in a reality that offers none? Perhaps the greatest challenge of an endless universe is not scientific, but human. Our minds evolved to measure fields, rivers, mountains, landscapes with edges we could walk to, horizons we could cross. Infinity is not something our intuition was built to hold. It slips through our thoughts like sand through fingers. And yet, across centuries, we have reached for it. In mathematics, in philosophy, in religion, and now in cosmology. The question of whether the universe has an end is not just about physics. It is about how far our imagination can stretch. Scientists continue to probe the darkness, measuring the faintest ripples in the cosmic microwave background, charting the distribution of galaxies across billions of light years, searching for the subtle fingerprints of curvature that might reveal the universe's true shape. So far, the results whisper the same answer. Space looks flat, endless and without boundaries. But certainty remains just out of reach, always one step beyond our current precision. Each new telescope, each new satellite extends our vision, and each time the horizon pushes back, as if the universe itself refuses to be cornered. And beyond the scientific quest lies the metaphysical one. If the universe has no end, then the idea of totality, of a complete set of all things, dissolves. There is no final tally of galaxies, no last star, no ultimate horizon. Instead, there is always more. In such a reality, our existence takes on a new dimension. We are not fragile sparks lost in a vast emptiness, but participants in an unending tapestry, part of a cosmos that has no outside, no beyond. The awe we feel gazing into the night sky is not the fear of edges, but the recognition of limitlessness. Still, the possibility of infinity leaves us with profound questions. Can an infinite universe have meaning, or does it render everything trivial, repeated endlessly? If there are countless versions of us scattered across the cosmos, does that diminish the value of our choices, our uniqueness? Or does it magnify it, showing that even in the face of infinity, this particular moment, this particular consciousness remains irreplaceable? These are questions no telescope can answer. They belong to philosophy, to poetry, to the deep corners of the human spirit. And so we return to the haunting question: what if the universe has no end? The answer is not a single truth carved in stone, but a spectrum of possibilities. Perhaps space is infinite and flat, stretching without limit. Perhaps it is curved and finite, looping back on itself. Perhaps it is only one bubble among countless others, each birthing new realities. What we know for certain is that the universe does not hand us easy endings. It invites us instead to live within mystery, to accept that some questions may never close, but will always beckon us onward. When you next look at the night sky, remember this: you are not gazing at a ceiling or a wall. You are staring into forever, into a reality that may have no boundaries, no final frontier, a universe without an end, and within it, us, searching, wondering, reaching out into the endless dark.